I'm going to give you a quick brief on the difference between simple interest and also compound interest. Let's start off with a quick game. Imagine I give you a choice. Option 1, take 1000 right now, no strings attached. Option 2, get 1000 every year for the 15 years. Which one would you choose? Think about it. Lock in your answer. Now, some of you are thinking, duh, 1000 right now. Others might say, wait, 1000 every year adds up to 15,000, right? So that's better. But here's the twist. What if I told you that both of these choices might be wrong? What if there's a way to grow your money even more without doing anything extra? Well, that's what interest does for you. But before you get too excited, let's break it down. If you take 1000 and hide it under your mattress, guess what? In 10 years, it's still 1000 and probably covered in dust. But if you put it in the right place, it could grow, multiply, and even double. This is where interest comes in. But wait, there are two types of interest. Simple interest, good but kind of basic, and compound interest, the real magic trick. Let's check them out. First, we have simple interest. It's like slow but steady worker. It's predictable, safe, and gets the job done. The formula is simple, just like its name. Simple interest equals to P times R times T. Let's break it down. P equals to principal, which is the amount you started with. R is the interest rate, percentage changed into decimal, and T is time into years. Example. If you invest 1000 at 5% simple interest for the next 3 years, how would you calculate it? It will be simple interest equals to 10,000 multiplied by 0.05 multiplied by 3 years equals to 1,500. Not bad. You earn 1,500 in 3 years, bringing your total to 11,500. Here's the thing. It's kind of like a turtle. It moves slow but steady. But it doesn't pick up speed over time. Now, this is where the magic happens. Compound interest is like snowball. Once it starts rolling, it just gets bigger and bigger on its own. Instead of just earning interest on your original amount, you also earn interest on the interest you already made. That's right, your money works for you. The formula looks a little fancy, but trust me, it's worth it. So the formula is A equals to P bracket 1 plus R over N bracket power of NT. Let's break it down so it's easier. A equals to the final amount, P is the principal, R is the interest rate, and N is equals to the number of times interest is compounded per year. Let me give you a quick example question. You invested 10,000 at 5% compounded annually for the next 3 years. How will be the calculation? A equals to 10,000 bracket 1 plus 0.05 over 1 bracket power of 1 times 3. And A will be equals to 10,000 times bracket 1.1576 equals to 11,576. Instead of 1,500 like simple interest, you now have 1,676 extra. That might not seem huge, but over time, the difference becomes massive. So, here's the deal. If you want steady, predictable growth, simple interest is fine. But if you want your money to multiply like crazy, compound interest is the real winner. But guess what? The earlier you start, the bigger your money grows over time. So, are you ready to learn how to use this to your advantage? Let's dive in.
So now we look at the simple interest question. The question is Emma deposit 4,000 ringgit in an account with a 3.5% simple interest rate for 2 years. So after 2 years, the rate increased to 4% for next 4 years. She planned to leave the money for 6 years but may withdraw 2,000 ringgit after 3 years. She also want to calculate the interest on the remaining balance after the withdrawal. So the question A is, what is the formula for simple interest and how do you apply it with different rates? So the formula of simple interest is I equal P times R times T.
A few moments later.
So the I is equal interest, and the P is equal the principal amount, and the R is equal interest rate, and the T is equal times. So how can apply it with different rates? We can apply it the formula for each period with different interest rate. For each period, calculate the interest separately, then add them together to find the total interest. So now we look at the question B. How much interest does she earn in the next 4 years at 4%? So the formula is I equal P times R times T. So the 4,000 is the P in the question. And the R is the 4%, we decimal to 0.04. And the T is 4. So the answer is Emma earned 640 ringgit in the next 4 years. So now we look at the question C. What is the total balance in her account after 6 years, including the interest? So now we must calculate the 3.5% the first year. I equal 4,000 times 3.5% to the decimal number 0.035 times 3, so the equal 420 ringgit. After 3 years, the interest earned is 420 ringgit. And the total balance is 4,000 plus 420 ringgit is 4,420 ringgit. So now, after 3 years, Emma withdrew the 2,000 ringgit. So the new balance is 4,420 ringgit minus 2,000 ringgit become 2,420 ringgit. So now we calculate the interest on the remaining 2,420 ringgit for the next 3 years at 4%. So the I is equal 2,420 ringgit times 4% to the decimal 0.04 and times 3. So it's equal to 190 ringgit 40 cents. So the total balance after 6 years is 2,420 ringgit plus 290 ringgit 40 cents equal 2,710 ringgit 40 cents. So now we can get the answer. The total balance in her account after 6 years is 2,710 ringgit 40 cents.
The next day.
Now, let's take a look at the compound interest case study question. Ame deposits 6,000 ringgit in a savings account that compounds quarterly. The interest rate is 5% per year for the first 2 years. After that, the rate increases to 6% for the next 3 years. Ame also deposits 3,000 ringgit at the end of year 3, earning 6% for the remaining 2 years. He plans to withdraw everything at the end of 5 years. Now, let's answer the sub-question. What is the compound interest formula and how does it change for quarterly compounding and varying rates? Step 1. The compound interest formula. The basic compound interest formula is A equals P bracket 1 plus R over N power of NT, where A equals to final amount,
P equals to principal amount, the starting deposit, R equals to annual interest rate, which is in decimal form, N is the number of times interest is compounded per year, and T is time in years. For quarterly compounding, we compound 4 times a year. So N becomes 4.
So we move on to B. How much interest does Ame earn for the next 3 years at 6%, including the RM3000 deposit made at the end of year 3? So we would use our compound interest formula, which is P bracket 1 plus R divided by N close bracket to the power of NT. So here our P is 6000 bracket 1 plus 0.05 because the 5% we change it to decimal, divided by 4 because compounded quarterly, to the power of 4 times 2 years. So what we will get is, we solve the bracket first, then the power, then we times by 6000, which we will get is RM 6,626 ringgit 0.92 cents. This is still not yet done because there's also another 3 years. So you take that same amount, 6,626 ringgit 0.92 cent bracket, use the same formula, 1 plus 0.06 because of the 6%, divide by 4 because it's compounded quarterly, to the power of 4 times 3 years. It says 3 years. When we do it, we will get RM 7,923 ringgit 27 cents. They are also asking, including the RM 3000 deposit made at the end of year 3. So, using the same formula, we will put P as 3000 times 1 plus 6%, change it to decimal, 0.06 divided by 4 because compounded quarterly, close bracket, 4 times 2 years. So what we will get is RM 3,379 ringgit 0.48 cents. So this is how much interest may earn the next 3 years at 6%, including the RM 3,000 deposit. So C, what will be the total amount in Ame's account after 5 years, considering all deposits and interest rates? So what we have to do is we take the answer from B, which is the end of the 6,000, which is 7,923 ringgit 0.27 cents, and also they're asking all deposits. So we take down the 3,000 deposit using the compound interest formula that we did on B, which is 3,379 ringgit 0.48 cents. So plus that too, we will get 11,302.75 cents, which is the total amount in Ame's account after 5 years, considering all deposits and interest rates.